Please welcome our special guest, Eric Schmidt.
Thank you very, very much. Okay, good. Thank you. Well, thank you very much. I'm so glad to be back here after a decade. I had the privilege of speaking to this group in 2008. I want you to imagine a microphone and a speaker in a room with a patient and a clinician. And as reference, it's important to know that in 1849, Elizabeth Blackwell became the first female doctor in the United States. So in her honor, and 170 years later, I'm going to call this virtual assistant Dr. Liz. What does Dr. Liz do? Right? She listens to the conversation, she disambiguates the voices, she follows the consultation, she gives suggestion to the clinician in his or her earpiece, right? She transcribes the situation so everyone has a complete record of all the conversations, and then she fills out and navigates the EHR. Now, if you're a doctor or a nurse, you love this product, right? What's it going to take to build this product? Now, speaking as your local patient here, I love this too, because the same microphone and the same speaker sit in my home, and I go, Liz, how am I doing today? And she says, I heard you talking about all the cookies you had yesterday, and you know you're overweight. Get back on your diet. Otherwise, you're fine. So then I ask her, how's my mom doing? And my elderly mother has given her permission to let me know how she's doing. And she says, your mother's doing fine. She's doing better than you. Pay attention. The important point is, this technology, everything I just described, is buildable today or in the next few years. All it takes is for all of us, literally every person in this room, to figure out how to build it. Now, I'm going to give you a roadmap, and I'm going to suggest some roles and places that everybody's going to end up with. But I'm going to start with get to the cloud. Run to the cloud, right? Don't stop, don't walk, don't think about it. Just run, take an airplane, fly to the cloud, whatever metaphor you care about. Now, most of you sit in institutions that have proprietary data centers which have some sort of logic about them. Most of that logic may have been true 5 or 10 years ago, but it isn't today. We now have much safer than your data center, much more HIPAA compliant than your data center, and much easier to use cloud-based servers within our industry. Google has a set of offerings, our competitors have an offerings. I'd prefer you choose ours, but choose any over 0, right? You get the idea. Now, why do you do this? The cloud is more secure, and I don't want you repeating the infrastructure work that we're doing. I want you all to focus on the innovation to achieve the vision that I outlined. Now, at the same time, a revolution has been happening in my industry that I want to take you through. And I've been trying to think about how to describe it, and my simplest answer is scale changes the rules. Scale changes everything. The combination of cloud computing, which you all know what I'm talking about, deep neural networks, which were invented maybe 10 years ago, and some newer algorithms, generally known as reinforcement learning, the explosion of data and so forth have allowed us to do these things. I'll give you an example that you can take a set of labeled data, feed them into one of our systems, which is called AutoML, and it will automatically produce the neural model that gives you the classification that tells you what's in the picture. It's literally just like that. That's how fast this is working. It's obviously more than just for healthcare. In terms of machine learning, which is what the primary progress in the next few years will be about, where does it apply? Medical records, I'll come back to that. Quantitative observations. There's this explosion of data, and I'll talk about that, that enables you to do enormous numbers of interesting things. And applying machine learning, I'll give you an example. Genetic variant calling is a process where we look at DNA and we say what variants are present. We open sourced a tool to do precisely that on this very large amount of genetic data that people are now assembling. Medical imaging, largely a solved problem. It's easy to understand if you remember that computer vision is now better than human vision, even for a perfect human vision. And none of us have perfect human vision, especially at night and when we're tired and all that. So the formula is data plus cloud plus the powerful networks plus deep learning and reinforcement learning. How do we apply that to all of this? And these sort of new interesting designs that people are developing have profound implications. There are people who are now working on what I would just call reverse random controlled trials. What they do is they take all the historical data and they look backward, they look at perturbations at the data, and they treat those as randomization events and conclude that a true random trial will produce the outcome that you're looking for. So this sort of new approach to doing experiments has a lot of implications. You take the data that you've generated, and there are new databases. I'll give you an example of something called the Data Biosphere project, which is trying to collect all of the genetic and essentially epigenetic and other data that we know into one place so that you can apply that into your algorithm. So in order to make this happen, and I'll come back to this, you need something that I'm just going to call a clinical data warehouse. In our world, the simple way to explain it is take all the data, all these diverse data sets, and just throw them in a big database. And we're talking about a big database, even by Google standards. You curate them into and normalize them into something reasonably usable. You take your sort of the vast computing resources that a cloud computing system refines, and you use sophisticated analysis on them with a rich API. So the conclusion you come to, speaking as the computer scientist, not the doctor in the room, is that you need a second tier of data. That the primary data stores, which are very important and will continue to be the EHRs in the medical system, will be supplemented, not supplanted, but supplemented with a second tier that looks a lot like an unstructured database of all of this interesting data that you collect from everywhere. And this is a key architectural point. This, by the way, phenomena has been repeated for the 40 years I've been doing this in enterprise software. So I know it's the path forward because I've seen it in so many other industries. So today, for example, we're very proud to have announced the Google Cloud Healthcare API, which allows you to take all the data out of the existing data stores, which are EHR and other proprietary data stores using FHIR, HL7 version 2, DICOM, a few other protocols, and put them in a normalized way into these new databases. And I'll mention a few classification examples. This is pathology. Relatively straightforward. You take label data, you basically train it, and then you show it another picture, and it can say that's a so-and-so. We've had enormous success with ophthalmology and with cardiology, with brain scans, with stroke, and analyzing vascular systems, for example. But to me, classification is the easy stuff. Now, it's hard for most people, and we've made it automatic with AutoML. But the really powerful stuff, right at the edge of what I do, is prediction. It's one thing to be able to classify. It's another thing to predict the next step in an outcome. But what I want is prediction, right? Because prediction allows me, or more importantly, a clinician, to intervene earlier. We have physicians inside of our company who believe that if these algorithms for prediction work, we can predict outcomes in the ER, for example, 18 to 24 hours earlier than any other observational system, because the deep analysis that can now be done against the historic data. We'll see if that's true, but I think they're right. So I'll use an example. Shakespeare in Hamlet wrote, "We defy augury," referring to us as humans, saying that we can't predict our own fates, but machines can. That's the point here. To me, that's what I want as I age. I want the computer and all of this work I've done in my whole career to be used to make sure that I have a healthy life, or at least a long and healthy life. So going back to when I used my Liz example, when Liz is whispering in the doctor's ear, she has not only access to the best practices, right, for detection. That's this classification that I'm describing. And remember, computer vision better than human vision. But more importantly, she can use new prediction algorithms to generate new life-altering recommendations that will essentially deliver it to me and to everyone in this room. Now, how this works is a technology called reinforcement learning. And the simple explanation is that it has a simulator, and it looks at forward outcomes, and it trains to see the optimal outcome. And we've done this successfully in a project called Alphago and AlphaZero, which I'm sure you've heard about, where in games, in complicated games, we can do much better than humans in problems that were thought to be unsolvable. We believe that the training data, literally the real-time experience that your clinicians in your institutions, small, medium, and large, we put it all together And we think we can build reinforcement learning-based solutions that can significantly improve the pathways of care that you all are doing every day. So put another way, a prediction means that the clinician will offer you a prescription ahead of when they normally would have, or a treatment ahead of it because of that. Now, another problem that's happening is that healthcare is becoming essentially an information science. A reasonable estimate is that as a person, as a patient, I have 5 gigabytes of healthcare data around, most of that being images of one kind or another. A lot of people think that there are at least 150,000 observations per day on patients that are just ignored per patient because they're all real time. There's no way to track them and store them and so forth. Can you imagine when we have the combination of sensor data plus continuous behavioral data, which you're going to get from your smartphone, and the various smartwatches that are coming, plus all the molecular data and so forth? This data explosion is profound. So let's look at some areas where we're getting some wins. And I was really shocked to discover this. Sudden cardiac death, #1 killer worldwide. There are roughly 5 ways for this to happen to you, and we don't want it to happen to you. Almost all of them seem to be predictable, and they're probably delayable, right? By just looking at the sequence of events in a person's life, we can probably intervene one step earlier and get them on the appropriate treatment. This has not been automated at the level that I'm describing. I'll give you another example, automatic reading of ECGs. Hospitals have billions of these ECGs just sitting there, and they've all been classified by humans who've read them. The current ECG approaches are generally, and the tools are generally thought by physicians not to be reliable for whatever reason. That's an obvious application for machine learning, vision, and so forth. I'm sure we can do that pretty much near perfectly. I'll give you another example, atrial fibrillation is a situation where you have an increased clotting risk, which can lead to stroke, and it's obviously a very bad thing. So who should be on blood thinner? Well, doctors have this complicated scale. Think of it as everything in medicine seems to be a 5 or 6-point scale. You know, you have this, 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 and if you only have 2, you know, we do this, and if you have 4, we do this. And those were developed over years of experience from the clinicians. But we can do so much better now to determine, and my estimate is that the mortality benefit, if we just put that in one of these systems and do the proper historical analysis, the mortality benefit in terms of lives saved is probably comparable to a new drug and far, far cheaper. I'll give you another example. I didn't know this, and again, we have doctors in the room. Maybe all of you knew this, but I didn't. That the retina, in particular the fundus, is a view into your vascular system of enormous value. Interesting. So it turns out we've just published a paper where we went through and we took retinal images and we accurately predicted heart risk factors more accurately than the doctors in our trial. In particular, age, sex, A1C, blood pressure, et cetera. Can you imagine a situation where we take that result, which is just the beginning of result, and then somewhere, some hospital runs an appropriate multi-year trial where they actually do retinal images and they train against what the doctors do so that when you start, right, and the first thing they do is take a retinal image and they say, we see the path of your disease now, and we know exactly when we're going to have to intervene unless you do A, B, or C, right? That's the kind of model that's predictive that's now possible. Now, this technology already works on diabetic retinopathy and macular degeneration. Those are relatively easy, but the power is this predictive capability. Another example is large vessel occlusion in strokes, right? We can now do this in a few minutes for a process that typically takes hours, and there's a startup doing that. Another example. There's a recent study about doctors and how they spend their time. And this is doctors and nurses. The rough answer is that they spend 2 hours of admin time for every 1 hour in front of a patient. No wonder 50% of the physicians report burnout in this situation. I'd feel the same way. That's not what they went to medical school for, did their residency, took on all that debt. They're actually there to serve patients, and instead they're serving the administrative system. And that's what they tell me. So, and by the way, the worst hit ones are the high pressure ones of ER, family, the sort of internal medicine ones, the ones where these decisions are so acute. There's another problem within the hospital community, which I'm just going to call alert fatigue. They've got so many different systems that are not particularly integrated that all these alerts are going on, and it's already a high-pressure situation. My God, right? What these people put up with, and how, by the way, how low we pay them, which is a separate discussion. So we can fix that by trying to figure out which alerts lead to good or bad, in this context, outcomes, and automate it. I'll give you another example. It should be possible with insurers and risk to automate and streamline when you see the patient's whole background in all sorts of interesting ways. There's this whole movement to value-based care, which obviously all of us support, and otherwise we're just never going to be able to afford what we're trying to do in healthcare. But we're in the Stone Ages now. 80% of the referrals and insurance interactions seem to be by fax, right? Well, that was really exciting in the 1980s when it became popular. Surely we can do better 40 years later with some of this technology. I mean, this is bizarre. How could we allow this? And the reimbursement decisions are made on the phone? I mean, this is what computers were built for, so humans could be doing things that are more powerful and better suited to what we're doing. So the sum of this, right, the reinforcement learning, the deep learning apply to heart disease, cancer, pathology, radiology, imaging, workflow management alerts, the transition to value, they touches everything. So let me do a couple of other examples to illustrate the power of what we can do. The consumerization that's going on is equally large and equally unaccounted for in the data architecture. Consumers, of course, are becoming much more demanding just in general. It is the on-demand generation. But look at it. Telemedicine is increasing. Mobile-based chronic disease management, people want to do that on their phones. Wearables are looking much more like medical devices. And everything is becoming much more user-friendly. Where is all that data going to go, guys? Right? At the moment, it's going to proprietary databases that's not integrated, and we don't get any value from it except for the app that particular vendor did it. That's precisely not how the internet was built. It's not how data networks are built. It's not how data science works. I can go on. The physical footprint of healthcare systems is changing. People are now going to the equivalent of CVS's and Walgreens clinics and so forth. How are we going to get all that data into this other place? Right? The only way to do that is using the principles of cloud and networks, putting it into these clinical data stores and so forth. And you could imagine an instrument at home. Well, that generates all sorts of data, right? Sleep patterns, right? Behavior patterns, eating patterns, and so forth and so on. So going back to the Liz example, Liz has information not just from what is going on in the medical context, but also has information, again, you've given her permission to do this analysis, around what's happened offline, right, on your phone and in your healthcare situation. Now, I want to emphasize that EHRs are incredibly important here, because EHRs broke through trying to get the data in one place, and they did a great job. So not only are they the revenue engine for the firms, the two large ones, and then a very large number of interesting ones that are serving smaller markets, but the sum of what they did in terms of revenue is crucial, and they also manage the workflow of the institution. Those two functions are going to continue and become more important for all the reasons that I've described. But I also think that Fire and HL7 version 2 development will not fully get the information out of those for various reasons, and that the conclusion that you're going to come to is that you're going to need this mid-tier data store for the reasons that I described. So when I look at this, and I'll finish up in the following way, when I look at this and I say, why is this not happening faster, right? And there's many potential reasons. After all, we've got the technology. There's no question the value of this. You can probably make some money from this. The startups are getting things, but there's something missing. And I will tell you that in all my years in other industries, there's a lack of the killer app, excuse the pun. There's a lack of something which causes all the data, all the interconnection, and all of these things to become rationalized. My own view, and I'll give you an example, people forget that Windows 95 did not initially have internet networking on it. It was seen as an add-on. In the 1980s, when I first started building email systems, they were seen as an app that was not particularly important and usable occasionally. Before the smartphone came out, every phone had non-integrated systems. The smartphone, which was, again, the killer app, as the internet was and as email was, forced that integration of all the data. Today, it's inconceivable that that was true. But it was true in my lifetime, and I helped build some of those systems that were faulty, so I remember them. The important point is that this transition needs not just one killer app, but another. The transition will go from workflow-based to voice-based. That technology is clearly in hand. But if you think about it, what we want is we want everybody practicing up to their level of license. We want the patient involved, but we want the doctor working at the doctor level, not at the administrator level. You get the idea. So put it this way, what does it take to make Liz? Well, you need a common digital health data store. You need normalized data from all the sources. We know how to do that. You need longitudinal trend analysis and then the kind of machine learning and reinforcement learning that I described. And the ability to predict next steps. Again, this is technology that exists today in one form or another. You need voice translation, transcription, voice generation, and multi-speaker disambiguation. That work is either done or underway. And you need language recognition good enough to do the text-to-speech and so forth. We're much closer than you think we are to the vision that I outlined. This is fundamentally a search problem. And Google is very good at search problems. And I think that all of you together working can provide all of the components that I described. We'll do our part, you guys need to do your part. Now, I will tell you right up front to finish, this is really hard, it's really humbling, and it's really complicated. But if we all work together, we can really save lives at a scale that is unimaginable because of the impact of these technologies. And I will make one prediction. So I spoke here a decade ago, and my prediction is at 10 years, if you invite me back, I will bring the equivalent of Liz to join me on stage. Thank you very much. Yeah, thank you.
Please welcome HIMSS President and CEO, Hal Wolf.
Here's Hal.
It's a beautiful day.
Hi, Hal.
Well
Thank
done.
you. Good. I think we agree.
Yes.
I agreed with your 6 points, Hal, earlier. So.
Well, I appreciate that. That was amazing. Where to grab a hold? Eric, you started off talking about you were here 10 years ago, and you gave an incredible forward view. But bring me up to date. If you go back over the last 10 years, and you see the advancements in healthcare, how have we done? What's changed?
Well, I want to start by saying that I think the arrival of the EHRs is a major story in the last decade, because 10 years ago, they didn't exist in the form that we know today. We forget they didn't exist. And before that, it was impossible to get the healthcare data. I know because we tried to build a product to do that, and it didn't succeed. So I know they didn't exist, and had they existed, perhaps our product would have been more successful.
Yeah.
So we should give credit to all the people who built them and made that architecture. It gives us the starting point. So thank you for making that happen. Another big change, I think, has been this move to value. And the move away from piece parting out medicine is profound. I can't imagine being an administrator in one of these ACO programs and trying to figure out which set of people I want to build my mix in the correct way. They have almost no tools, almost no data. What are they doing, using spreadsheets? I mean, my God, right? We've got to be able to do better than that, right? And that's, again, a classification machine learning problem.
Yeah.
And then I think the third issue is this recognition that consumers are going to be much more involved with their healthcare. This is the smartphone revolution. Every patient you see now has a smartphone.
Right. But this gets to an interesting question. And when you're looking up and you're saying, okay, here's where we are. We need the actionable data that we talked about. What's going to create that leap? What's going to be the examples that take us from point A to point B? How do we begin to take more than the EMR data? How do we get it in a corrected state? Because it's not exactly fully clean every day of the week.
Yeah. So clinicians will do whatever it takes to serve their patient. So my visits have shown a mixture of tools that are all sort of, and you ask them and they say, well, I use this for this and this for this, and can't you guys like make all this work together? And I sort of don't really say anything at that point. So what we know is that if you build a specific tool that solves a specific problem, I'm thinking Hippocrates and the prescription drug stuff, you and I talked about that a while ago.
Yep.
These have been around for a long time. So we're on a path right now to building very powerful tools that require the practitioner to move from their traditional screen to some smartphone or some app, and then they have to link it together and so forth and so on. So I think that the specific apps are going to come. And they're going to come because I've met with the startups. They're really powerful and they will save lives. The problem is that because of the way it works, they solve a problem, right?
Right.
They haven't solved the general problem. So in the language of Google and machine learning, what I would say is you should put the data in a HIPAA-compliant cloud data store. You should run BigQuery, which is how we do these complex queries. You can ask a question, show me all the people that have this gene that have not been treated for this outcome. Throw that data into what is called TensorFlow, and then build a classifier against it. If you do that as a technical matter, right, you've built a system that automates all of that in a way that's very powerful.
But getting that data line, driving the demand for us to break through, for lack of a better term, the lack of interoperability, or getting the data lined either from semantic or from the ability to get into the first and the second tiers you talked about earlier. Is it going to take a killer app? Is it going to bring us something that we just don't have today to get the full alignment?
I believe it will. And I'm not suggesting there's just one killer app. When I think back to my own history, there were many killer apps. I used 3, the smartphone, the internet itself, and email, but there were many others. But you need something that drives the interoperability. Now we have, I was part of the original proposal in 2009 that proposed FHIR. And FHIR, which is built on the JSON protocols and so forth, covers maybe 20% of the data that's available, some number like that. And people are working hard to extend FHIR, F-H-I-R, by the way, not the other FHIR, to handle all these cases. But it's not fair to the FHIR people to say, why don't you have all the data?
Right.
Because at exactly the same time, the EHRs and the other data repositories are adding even more interesting and more powerful data, which they should be doing, right? Makes perfect sense, right?
Yeah.
So you'll never get 100% alignment. So the best thing to do is to try to focus on the FHIR interoperability, which we're working hard on, to make sure that this next generation of startups, there's an interface called SmartFHIR, which is a way of triggering these apps and trigger them into the workflow of the existing EHR. And that will get them started. That will get them some revenue because you'll buy the stuff from them. That'll get them some learning while we get ready for the data integration solution that I talked about.
Now, I read somewhere that Google had some expertise in consumers,
Yeah.
and I didn't know if that was a part of the background. But all kidding aside, what do we need to be thinking about from a consumer standpoint? Healthcare has been making a fundamental transition from very institutionally based to reaching out and getting more focused. But what is that relationship like with a consumer? Where do we need to be thinking about how we relate?
So some of the studies that I've seen have indicated that Google searches, maybe 5% or so of the searches are medical related. So that's important that that be done well, and we have our own, what we call one boxes that we generate that try to have responsible medical information for situations. One of the earliest, not apocryphal, but the earliest stories at Google was when the company was very small, just as I joined. And Sergey actually read this out to the employees, all 50 or whatever it is, and said that I had my symptoms, I typed them into Google, and it said, the first result was, you are having a heart attack, call 911. And so he did, and he survived. And we took that as, okay, that's a big deal, right, to think about. Imagine if we'd said, you're not having a heart attack, right? Think of the moral burden there.
Yeah.
More recently, we've created a company within the alphabet world called Verily, and they are working on quite a few interesting consumer products. Their first success was on a glucose monitor in your eye, right? And it's the world's smallest battery. It's a tiny little computer, and it goes into a contact lens. Now, the way Verily works is they're essentially an R&D lab, and they work with the large providers in the consumer space. Because Google itself, what do we know about getting those things certified and global distribution and all the things that are needed? So Verily pioneered a model where we build this R&D and then we do joint ventures with people. So we have now joint ventures around heart health, around diabetes, right? A number of things coming out there. a whole bunch of things around vision and many other things coming.
Yeah.
So likely if you use a Google product in a consumer space, it'll come through a Verily partnership with an important partner.
Well, I've had the pleasure of the last couple of years of visiting at Verily and looking at some of the products and services that they have been creating. And sitting behind a lot of this are components of artificial intelligence, machine learning. Let me, if you don't mind, take a half step back, and can you just give us a definition of it, and let's demystify it a little bit, because it is becoming a commonplace phraseology, but how would you define it?
So artificial intelligence, the term was defined in the late 50s, and it generally refers to computers that exhibit human-like behavior, right? This does not mean robots that are killer robots, that's movies, but things which are sort of, you say a human does that, well, a computer does that too. Machine learning is really the term of art now for using these large data stores to come up with interesting insights. So the way I've talked about it publicly is I've said, look, I think we're going to coexist with these things. Right? Humans are very good at judgment and intuition and flights of fancy and sort of creative stuff. And all that boring stuff, the computer is really good at. And furthermore, it has a much better memory than you do, especially if you're drunk. Right? So you get the idea, right? Follow the reasoning.
I can't relate, but keep going.
Okay. Well, there must be one person in the audience who got that one. So in any case, computers are very good at doing the precise things that we as humans find very, very boring. Filling out forms, doing deep analysis. I'll give you another example. I'm sitting there with the doctor who discovered that with diabetic retinopathy, we do much, much better than the humans. And diabetic retinopathy is this terrible disease where you have diabetes, and then there's this change that occurs in the back of your retina, which is visible if you look carefully enough. If you're an ophthalmologist, you look carefully enough, they'll see it, and then there's all sorts of treatment options. This is a problem that exists especially in the developing world where they don't have enough doctors per patient. So it's a real problem. And the way you solve this is by taking pictures. And I said, well, how in the world are you better, right, Mr. Doctor who works at Google, compared to all of the best ophthalmologists? And he looks at me and says, I'm not better. I just saw 1 million eyes. Right? In other words, it's not that we're better. We just saw more, right? And trust me, whatever number of eyes that the ophthalmologists study, we can beat them with our computers, right? It's not that hard to understand when you think of it as they're good at the things that we're not so good at or we get bored by. Yeah. There are another interesting statistics that there have been tests, not ones that we've done, but others have done, where I'll use skin patches as an example, dermatological patches, and they'll show a large sequence of dermatological patches, and every once in a while they'll repeat the same picture to see if the classification is the same. Now, speaking as the local patient, I want the correlation to be 100%, right? So every time the same picture shows up, I want to have the same answer, cancer, non-cancer, whatever. It's a long list of dermatologist classifications. It turns out in that particular test, the coincidence or the times where the diagnosis was the same was about 70%, not 100%. Now, computers can do that at a much higher level. So the point is that there's just things that doctors do that computers are better, and doctors do a whole bunch of things that computers are not as good at.
Is there a dark side to this? Is there a negative or a downside that comes with AI or machine learning?
There are many concerns about the technology. Our industry is obsessed about this. It's transforming every company. Google has gone from being mobile first under my leadership to AI first under the new CEO, which is excellent. And I think most people would say that transition makes sense to their companies. There are a lot of concerns, for example, that biased data in will produce biased training.
Right.
So a typical example is that let's assume your training data set is discriminatory against a minority or women or so forth, and these things do occur in medical health data sciences. Then you're likely to produce a biased result in your training. Bad training in, bad outcome.
Right.
So there's actually a whole field within AI around this question of discrimination and trying to determine what algorithms we can change to identify bias that's systematic and then actually eliminate it, because nobody wants that.
we often think about AI as a future state, but there's AI that's already being built into many of the applications. What are some of the examples that if when we're walking around the exhibit hall the next day, where will we see AI already?
Well, there are many. The easiest ones to use are all of the speech things. So the various speech integrations that Google does, that Apple does. If you use Siri, that's an example. If you use Google Translate, that's all done with machine learning. I was shocked to discover that these technologies do not have dictionaries. They don't have databases. It's all learned. And if you simply show these computers enough paragraphs of Spanish and English and Russian and English, right, it turns out that they can discover that structure. We now have results in research using reinforcement learning where we can actually build a single model, and then if it hears a new language, it can basically impersonate it immediately. That's how powerful these technologies are.
Wow. How do we accelerate? So we're sitting in a world, we've talked about the killer app, which is true. We've got pieces of this in the language that are already amongst us. Is there something we can do when we walk back into our domains tomorrow to help in that preparation?
So, and I'm sorry if I'm being obnoxious in my comments here, the stuff's happening too slowly because you've not moved to the kind of platforms that scaled my side of the industry. You've not moved to complete interconnection. You've not moved to data architectures that are open. You've not moved to the cloud. And I'm ignoring the machine learning, which is relatively new.
Sure.
But over and over again, my view of the sum of the IT industry is that it's conservative beyond where it should be. So let me say again, you care about security, the cloud is going to be more secure than your data architecture. You're worried about your medical data being stolen by the bad guys and sold, right? A very legitimate worry. It's going to be safer in a cloud-based provider. It's just true.
So that's a risk which is reduced by where the data is held and where the processing occurs. There's another component in healthcare, and this starts to get to that predictive modeling that you mentioned, which is the risk or the liability, if you would. How do we start to think about the balance? Because today, we take so much of the information that comes from systems, we bring it out of clinical decision support. We need that validation from the physician or the clinician. It begins to start to shift the risk, right, if you would. How does that start to play?
So I want to be clear that for the discussions of AI and machine learning, the decision maker should not be the computer because it makes mistakes. And one of the problems we have with respect to AI right now is that not only do they make a small percentage, but nevertheless a small percentage of errors, but we as an industry cannot explain those errors. So, you know, my standard joke on this goes something like, we have a self-driving car that's been trained by some startup, and they trained it by driving along. And I'm driving, and I don't know if you all do this in Nevada, but in California, there's this thing called the California rolling stop. We don't quite stop the car. So the car does that, and the policeman pulls me over, and the policeman says, "Why did you do the rolling stop?" And I say to the policeman, I wasn't driving, officer. And he looks at me and he says, "Well, who was?" And the car says, "I was, officer." And so the officer says to the car, "Why did you do the California rolling stop?" And the car says, "I don't know." Truthfully, because it was trained, and it's one of the things it learned. Now, there are, again, many research projects working on this issue, which have technical names, to make sure that we can actually explain the behavior of these networks and so forth. So for things that are life critical, I want a human in the loop.
Right.
I want a nurse and a doctor, a real expert. And I want them to use computers as data sources, along with their good judgment and colleagues and so forth. And I want them to be in charge. In my vision, the doctor and the nurse, the clinicians, are more important. And if you believe anything close to what I said about the 2-to-1 ratio, we should be able to get a significant proportion of improvement of productivity out of our existing doctors. And by the way, in case you haven't noticed, there's a doctor shortage. Plus, we're all living older, which is a good thing, right? So the doctor shortage is not going to get better, right?
It's not going to get
And I'm not in favor of having life extension be shortened, right? So let's try to deal with the reality. We're going to have a lot of older people. Their needs are going to be higher. We need to help automate and make these clinicians even more productive. And we can do it, and they'll be happier as a result.
So we have a shift coming. We can maintain the risk. We're going to have the human intervention of it, which is still a critical part of the formula. We talked a little bit in the opening, and you talked about the 6 points, about the geographic displacement that we have. This seems like a tremendous step forward in being able to do diagnostics at great distance and really helping understand where we need to be in the delivery of care.
So I'm familiar with 2 examples. Cleveland Clinic has done this thing called the tele-ICU. It's very successful. Again, their extreme knowledge applied to that. Mayo has done a tele-neonatology unit, which I'm familiar with. Again, incredible results, right? Because they have that concentration of knowledge. So my question is, and these are expensive to set up. So my question is, how do we scale that? It's the scale question, and you mentioned this in your opening arguments. And I think the answer is with an increased level of automation. In other words, having a doctor manage even more automated systems and watching for errors, watching for things, and signing off on final judgments, we can have doctors be even more productive. And again, especially when you think about the developing world. I was in Myanmar. It's a beautiful country. And I was talking to the guide, and I said, well, tell me about the healthcare system in your country. They had just come out of the military junta, and they said, well, it was like a strange question. She spoke English. And well, okay, so I tried a different question. What happens when you go to the doctor? And she said, well, we don't have a doctor. And I said, well, we're in a rural area. Well, where would you find a doctor? Well, we could go to the city, but we don't have the money to go, right? That's why I work here. And I said, well, what happens when people get, really sick? And she said, well, they die. I mean, it's one of those really humbling statements. We take for granted in our developed world that the access, even if you're complaining about it, it's long waits and so forth, that it exists, okay? The majority of humans, right, our fellow brethren, men and women of our same kind, don't have access to any health care. I can think of no higher calling in figuring out a way to take the pieces that I'm describing, which needs to be done by some very clever doctors, right, and figure out how to scale that not to 10 people, as in these tele examples, but in 500 people and 1,000 people, right? And we have this sort of core issue around cost. Now, we can debate whether cost in aggregate is going to go up, but we know that automation of this kind reduces the cost of specific treatments and has all sorts of positive benefits.
Sure. Our clock is running, both figuratively and literally. But as we look up and we see the silver tsunami coming, when we talk about the gaps that we have, what do we have to do to accelerate? Because the fear that many have is literally in the next 5 to 10 years, we're going to hit a crisis we may not actually appreciate. And we'll be talking about that tomorrow. So how are we going to shorten this timeline? Because right now, our adoption of new technology, it worries me if we're really on a 5 to 10 year scale.
I think, by the way, this is why you took the job, to work on this problem. We were talking about this.
It's true.
I would say to all of you that, first place, demographics are reality, right? So the demographics of our future is understood. And what you said is just true. You can't deny it. It's going to happen, right? So what are we going to do about it, right? So in the American way, we're going to use innovation. We're going to talk about it a lot, and we're going to ultimately have free market solutions that will get us there. That's how we work as a country, and it's a good way to do it. I can think of no better way to address both revenue concerns as well as healthcare concerns as to the combination of moving to cloud and then using machine learning tools of the kind that I've described, right, to address this. In order to move to the cloud, you also have to get your EHR vendors and all your other data vendors to use FHIR HL7 version 2 interfaces along with DICOM and so forth. As I mentioned earlier, that work is underway inside your institutions. I think you basically need to hire more engineers, right? Sorry to say, but a small number of engineers who could take what I just outlined and get it integrated will give you so much economic value in terms of cost, profits, expense coverage, the ability to hire additional doctors, and to fund the kinds of things that we really want to do.
Well, in our closing minute, my question to you really is, what would be your message to the healthcare community?
Well, I think you're late to my world. You're ahead in many areas, but you're late to the kind of stuff I'm talking about. And you're late there for many, many good historical reasons, but it's 2018, right? It's time to move forward. And the moving forward is internet. I gave you the formula: data, cloud, network, reinforcement learning, machine learning, integrated solutions, big data stores. The power of big data, the ability to get these insights, is unimaginable when you actually see it. When you say, oh my God, another stupid example. So we think we have the best engineers in the world. And every company does, but we're sure we're right. So we have these data centers, and our data centers are massive. And our data centers are incredibly important to us, and they use a lot of energy. So the DeepMind group did a program where they looked at data center usage. This is literally power, fans, cycling, and so forth. And using these algorithms beat the best human designers by 15% in our data centers. I mean, 15% is more than the profitability of most companies. Imagine that solution, separate topic, applied to power generation, gas generation, oil generation, things which need to be efficient. Imagine that 15% applied to the provision of healthcare using the same algorithm.
Amazing.
That number is higher than the profitability of almost every healthcare institution I know of. That's how powerful this stuff is.
Fantastic. Eric, I did wish we had more time, but
thank you all,
so much.
and good luck. Thank you, Hal. Congratulations.
Thank you.
Thank you.